This short video will demonstrate how to design a shear tab connection, which is also known as a single plate connection, in VAConnect. Let's get started. In this example, we will design a shear tab to connect a W16 by 36 to the web of a W14 by 90 as shown in the detail. VAConnect designs all shear tabs using the extended configuration outlined in Part 10 of the AISC Steel Construction Manual. Since this connection will be used at two different locations in the project, we will design it using two load sets. The shear tab in this example will resist both shear and axial load. VAConnect accounts for the interaction of the eccentric shear force and the axial load by following the design examples produced by AISC. We will start out in VAConnect by adjusting the geometry of the connection. Selecting the beam, a W16 by 36 will be chosen from the shape database. In the material database, we will select A992 grade 50 steel. Next, we will adjust the thickness of the support to equal the web thickness of the W14 by 90 beam. And we see that grade 50 steel is already selected by default. Selecting the shear tab, we will increase the number of 3/4 inch diameter bolts from 2 to see if 3 are sufficient as a first try. The bolts need to be 9 inches from the support for the geometry of the connection to work. Note that the shear tab is a 1/4 inch thick made of A36 steel with a 3/16 double-sided fillet weld. The last thing to do is to set the beam offset to 7.5 inches. Looking at the project status, we see that the shear tab detailing is okay since the numerous detailing checks passed. Now we can move on to apply the load to the connection. For our first load set, we will enter values for the dead load, the live load, and the wind load, which is in tension. Then we will create a second load set and enter the values for the dead load, live load, and the wind load, which is now in compression. With the surface level loads defined, we can go to the load case manager and select which building code we want to use for the load combinations that are automatically implemented. With the loads specified for the connection, we can now turn our attention to the project status to see all of the limit states that are automatically checked. Immediately, we see that 3 limit states are failing. Clicking on Bolt Group Shear, we can see the detailed calculations and we can view which load set and load combination controls. In addition to bolts failing, we see that the bearing on the shear tab fails and that the shear tab yielding/buckling interaction fails, which accounts for the combined shear, axial, and flexure loads on the shear tab. Switching back to the model view, we can quickly modify the bolts and shear tab to get all of the limit states to pass. Increasing the number of bolts from 3 to 4 causes the height of the shear tab to also increase, and all of the limit states now pass. Alternatively, it might be more economical to use only 3 bolts that are larger in diameter with a slightly thicker shear tab. Making these adjustments is effortless, as VAConnect allows us to quickly adjust the various parameters to create an optimal design. With the design complete, we can switch to the report view to easily create a report to document our work. A concise design summary is automatically generated, showing the maximum unity values for each limit state. Also, information on the model and loads can be included in the report. Detailed reports that show the calculations for each limit state can be added to the report, along with summary tables for each limit state that show the values of the various parameters for the limit state and show the unity values for each load set and load combination. In just a few minutes, we have used VAConnect to create an optimal design for our shear tab connection and produce a report to document our work. To try VAConnect for yourself, head over to our website and download the free trial.